Hi everybody, this is Dr. Dan, and I'm going to do our biomaterials lab where we're working with hydrogels. I'm going to basically be doing the same thing I would ask you guys to do, except I'm going to do it a little bit different because I'm going to make all my gelatin and agarose for both the mechanical testing and the stuff that we're going to sterilize, and so I'm going to show you how I can sterilize that in the autoclave. So I have everything set up here. I'm going to start weighing stuff out, and then we'll dissolve it. I'm not going to give you the actual numbers because part of what I'm going to ask you to do is you do all the math for me, and that way you'll be able to better understand what's going on. I also have a water bath because I'm going to heat up some gelatin. We're going to do something a little special that's not in your protocol. I'm not only going to use the physically cross-linked gelatin, I also have some methacrylated gelatin that we're going to use photo cross-linking for and see how that works and compares to our other gelatin. And I'll talk about that when we get to it. But let's start off by weighing out our gelatin and our agarose, and we'll start heating it up and letting it dissolve. So I've already done the math over here of what I want to weigh out in my lab notebook. So you guys could certainly do all that math as well. Again, I'm going to have you guys do the math at home. But let's go ahead and get to weighing out. Okay, so over here on the scale, I'm going to use my weighing paper. I usually like to fold it in half each way so that it makes it easier to pour into the bottle. I'm going to stick the weighing paper on there. I want to tare, make it 0, and then I can weigh out whatever I need to weigh out. Starting with the agarose. And, you know, this has doors on either side, so one of the easy ways to do this is reach in like that, reach in, and then you can put your agarose on the weighing paper. Okay, so I weighed it out. It's in here. I went ahead and brought the bottles over here. I forgot to do that before. I'm going to go ahead and just pour the amount I need in the bottle. And of course, I recorded exactly how much I weighed out in my lab notebook so that I know how much to dissolve the agarose in. I'm going to do the same thing with the gelatin. Okay, I did clean off my spatula so that I wouldn't get agarose in the gelatin. And again here, when we're weighing this out, you don't have to be exact. Okay, we just want to know about what we want, and then we're going to dissolve it in the amount of water that gives us the percentage that we want. Again, once I have my gelatin, I'm going to pull it out of here and gently pour it into the bottle. Okay, now that I've weighed it out, I need to go ahead and recalculate what volume of water I need to dissolve this in. So I will do that now. Okay, now I've done the math in my lab notebook and calculated what I need to do. I have some water that I'm going to go ahead, this is just DI water, and I'm going to use the cylindrical pipette to do as best I can. Like your math may have been pretty exact, but we're going to do the best we can as far as dissolving each of these in the correct amount. So I have a 50 ml pipette tip here. Okay, and you might have done the math and seen that, you know, came up with a really exact number to 2 digits, but, you know, honestly, if I'm looking at this thing, the best we can kind of do is almost 1 mil, maybe 1.5, you know, maybe a half increment at a time. to get a good estimate of what our volume is. So that's really the best we can do. Now we're just going to dissolve these. The way we got to do it is we're going to heat it up. The gelatin doesn't need to be as hot. The agarose needs to get pretty hot. It needs to get closer to 100 degrees, so I'm going to turn it way up. I'm also going to turn on the stir bar, which will help mix things. I don't want to stir it too fast, just to get it going. The gelatin is already really thick, so it's going to take some encouragement to get the stir bar moving. And you can see it's very unhappy. All right, so I'm going to get a spatula to break this apart a little bit, because it's kind of stuck. It's just goopy in there with all that gelatin, and we're dissolving this at a high percentage, 20%, so you can see how goopy it is. So this will help break things up to start, but really the heat is what's going to help dissolve it. Okay, it's just so goopy. We're going to let it heat up. Let's see if we can't get things going. I'm going to cover these a little bit because I don't want to get too much water evaporation out of there. Okay, and it's going to take a while. So in the meantime, we're going to work on our photo-initiated hydrogels. Okay, we already have this alginate is already boiling very fast, so I'm going to turn it down. That's faster than I expected it to dissolve. And we are already very close on the agarose, or the, sorry, this is agarose. Okay, we are definitely dissolved on that. It's definitely boiling. So that, I'll tell you right now, I probably set that for too long because I was paying attention to the photo initiator stuff. The gelatin is getting close. It's not quite there yet. And so really we do want to keep this warm. We don't want this to harden back up. But if you remember, what we're going to do is we're going to make some gels for mechanical testing of just the agarose only at 0.5%. So remember, we dissolved this at it's currently at 1%. And so we need to dilute it with water. And then we will put it in a 6-well plate to make a gel for mechanical testing. And then we want to also make gels that are 10% gelatin and 0.5% agarose. And so if we mix those half and half, this is 20 and this is 1%, that will get us there. Okay, so let's go ahead and start getting ready for this before we go on to dissolving our methacrylated gelatin. We need our 6-well plate for this one. Okay, and so if you follow the instructions, we're going to have 2 that are agarose only. So I'm going to write AO, AO, and 2 that are agarose plus gelatin. Okay, and then we're going to have 1 well that's going to be methacrylated gelatin, and then 1 well that's going to be agarose plus methacrylated gelatin. And so I abbreviate methacrylated gelatin gel MA. Okay, so this is going to be our 4 wells. If we want, we could go ahead and add the agarose now. Gelatin is getting close, but we'll keep an eye on it. That's hot. And so I want a total of 3 mLs in that, and 3 mLs in that. So I need approximately 6 mLs total. I probably will get a little bit more just to make sure I have enough. And so, like, if I add 3.5 mLs of agarose plus 3.5 mLs of water, and I'll actually go ahead and use this. This is DI water that I started with the water bath. So I'm going to go ahead and use that for my water so that it's a little bit hotter already rather than cold water, so it doesn't prematurely. That'll give us 7 mLs, and then we can put 3 in each of these. And so I'm going to get a 5 ml pipette tip to do that. Okay, so I'm going to go ahead and label one of these tubes agarose only for convenience, A0, AO. Now I'll go ahead and get the water first. I said I want to get 3.5. We want to do fairly accurate on this because we want it to be the right gel the consistency of 1.5%. Okay, and now I can go ahead and get some, like I'm not so concerned about contaminating things, right? Like it's just water. So I'm going to get some of the agarose. I do want to be a little bit quick because the agarose will want to harden. Just mix these a little bit. So I'm going to get 3 mLs. Oh, I better open my thing first. Three mLs in here. Three mLs in here. Okay, so we're done with this. Be careful about bumping that next time, Dan. And now I'm going to have agarose plus gelatin in this 15 ml tube. So I'll write A plus G. Our gelatin actually looks pretty good right now. It's close, but not quite there yet. With our agarose plus gelatin, I'll do the same thing as before, where I add 3.5 mils of gelatin and then add to it 3.5 mLs of the agarose. In this case, I don't want to mess up the agarose with the gelatin, so I'm going to get a new tip for this one. In there, I'm going to mix it up. Try to avoid making bubbles. And I can go ahead and put it in my 6-well plate here. Use 3 mLs. I'm doing this kind of slowly because I don't want to make bubbles. I end up with a few bubbles anyway. Hopefully by the time it hardens, those bubbles will be gone. Ooh, that's bad. So I can suck up bubbles like that. Okay. Okay, and that's the extent of the cases we wanted to do according to the lab protocol that you guys have. So like I said, this is just kind of bonus doing my photo-initiated stuff. Okay, I'm going to go ahead and set this plate in the fridge just so these will go ahead and harden for us. We'll go ahead and cut out these gels that we're going to save for mechanical testing purposes. And so I've already filled a couple of tubes with just water because we're going to store these in water to keep them hydrated. So I want to make sure I label the tubes. There's going to be 4 cases, right? Agarose only and agarose plus gelatin, right, are the ones that are described in like your lab procedures and the ones that I would normally have the students do every semester. So you guys get lucky that we also have these methacrylated gelatins and the agarose plus methacrylated gelatin. Okay, and normally I'd also need to put my initials and date on these because you never know what will happen to me. And you'd hate to have a bunch of stuff that nobody knew what it was floating around. All right, so we're just going to use this 8 millimeter biopsy punch to cut things out. Come on out. And we can use the same punch for all of them. It's not going to contaminate each of them. And so the normal procedure is to cut 2 from each of these agarose only and agarose plus gelatin. That way you just have plenty of surface area in case you mess up. So because the gelatin methacrylate was so expensive, we only made 1, so I'm going to have to get 4 samples out of that and not screw it up. Again, we used all $200 worth of gelatin methacrylate for this little experiment, so you know, if this screws up, then we've just flushed $200 down the toilet. So welcome to research. Okay, so let's start cutting these out. I'm just going to cut, pressing down. All right, and this is always the trick, is scooping these things out. That worked out really well. So this is agarose only. Sometimes it's even, you can even consider like pulling up around the gel and leaving the cut out one there. If you're having issues, that's a possibility too. Problem is when you do that, you destroy any chance of having like some spare spots. But okay, those were the easy ones. Those were the ones that I was less concerned about because I know students have done those in the past. So I'm going to try to do these now. I am going to try to probably pull away some of this other gel to help me, give me some leverage. Okay. Not too bad. So this is the gelatin methacrylate. Okay, so we've saved all our gels for our mechanical testing, and we will do that later. But in the meantime, we're kind of done, so I can play with these and kind of feel them as much as I want. Right? I can tell you right now that this gelatin methacrylate, it is holding together, but it does feel weaker than the other ones with agarose in it. And the one that's pure agarose at least feels the stiffest to me. Okay, so I'll throw all this away. And we are done getting our gels ready for mechanical testing.